Hello, good evening everyone. Today we are going to discuss about introduction to arrays. Now, first of all, we might know what arrays actually are. So, array is nothing but a collection of elements of the same data type stored in a contiguous memory location. Now, what I mean by contiguous is suppose that we have a memory location like this. Now, if we want to store the elements 1, 2, 3, 4, and 5, what array will do is it will store first 1 in the first location, then 2, then 3, then 4, then 5, and this is the array that we have right now. Now, what array did it? Array is an index-based data structure. So what index based actually means is this is the first element, which is the zeroth index. This is the second element, which is the first index. Now, this is the third element, that is the second index. Fourth index, fourth element is the third index, and the fifth element is the fourth index. So, what array will do is array will store these elements in this fashion. Now, if I have to, one more thing about arrays. Now, see. The arrays are fixed in memory size. They are fixed in size. That means once the array has been created, once this array has been created, we cannot extend or decrease the size of this particular array. Suppose if we want to increase the size of this array, what we will need to do is we will need to create an array that is bigger than this array, copy all the elements over here, and then delete this entire array. Delete this entire array from the scene. So that is what happens. Now we have a bigger array. So that means that arrays once created cannot be increased or decreased when it comes to their size. Now, what are some of the characteristics of the array? Arrays store same type of data. Remember the example I gave you? Remember this example? Array will always store same type of data. Now suppose that I have an array 1, 2, 3, 4, 5. Now this is my array. What are these? These are integers. These are integer variables or elements. These are integer elements that are stored in an array. Do you see any characters or strings or anything? Not even a float. So that means array once declared. This is the declaration of the array. You can see that we are declaring the data type of the array. We are declaring that this array needs to be of int type. Now, what int type means is that this array will only accept integer variables and nothing else. So this array will only accept 1, 2, 3, up until 1 to infinity, up until the ranges is only up to int. All right. Now, Now, one more thing about arrays is that they are index based. That means, suppose we have an array 1 and the first element is 1 and the last element is 100. Last element is 100. Now, we have to access these elements. So, what we do is we simply write ARR 0. It will give us the first element, that is 1. Now, ARR 100. So, ARR 99 will give you the last element. Now we can see that accessing any element in the array is a constant runtime. It is an operation of big O of 1. It is a constant, it is a constant runtime operation. We do not need to do anything for that. We do not need to run loops, do some functions, do some mathematical calculation. Nothing of that sort needs to be done. It's very simple and straightforward. Now, this point was already discussed in the last slide that once this array has been created, we cannot change, increase, or decrease the size of it. Now, if we have to increase or decrease the size, what we can do is we can make another array bigger or smaller than this one. Suppose that this array is bigger than this one. So what it will store is it will have 99 plus some more elements over here. We'll have to manually copy all the elements over here. Now, manually copying all the elements is a time-taking task. Now, suppose we have 100 elements. We have to copy 100 elements from old array to the new array. What is the time complexity that it might take? It will take hundreds. Let's just suppose that each element takes 1 second to copy. It will take us 100 seconds to copy. Now, suppose the size of array is infinity minus 1. How much time will it take? It will take us infinity minus 1 time just to copy elements from the old array to the new array because we wanted to change the size of the old array. So whenever we declare the size, what we do is either we declare the specific amount we need, suppose we need 5 elements, we'll declare array of 5. But there are cases when we might need some extra locations. So what we do is we'll just declare array of 10. We'll just declare ARR 10. But whenever we use, we'll only use ARR up to 5. Now the rest, 5 locations are for future use. Let's suppose we need, this is the same case what we do with our phone's storage. Suppose I am purchasing a phone that has 128 GB of storage. Now 128 GB is static, it is there. Once I purchased, I cannot go back to the shopkeeper and say that please buy a, let's just make it 256 GB without changing the phone. Now what we can do is instead of that, or we can just purchase a 256 GB one, knowing that 128 GB will take hardly a week to be full. So what we do is we purchase a 256 GB one just to make sure that we have extra space in future whenever we need. Now, traversing arrays. What actually traversing means? Traversing is the process of accessing each element at least once or exactly once. Now, suppose that we have 1, 2, 3 up until 10. If we traverse this array, if we traverse this array, what it will do is it will visit 1, then 2, then 3, 4 up until 10. So this is traversal. Now, as you might be guessing, this is an order of n. Traversing an array is an order of n because suppose there are infinite elements. What is the traversing time? It will take us infinite time to traverse the whole array. Now, this is a simple C snippet of how we can traverse the array. See, first of all, this is our array. Now, we do not know the size of this array. We do. Actually, we do know the size of this array. So the size is 5. But just to have a standard code, what I'm doing is I'm taking an integer n that I'm saying that the size of this array is 1, 2, 3, 4, 5. 5. The size of this array, 5, divided by the size of first element. Now, 5 is the size of element, 5 is the number of elements in the array. Each element is of 4 bytes because this is int. So 5 into 4 is 20. Now, 20 has to be divided by size of the first element of the array, that is 4. That leaves us with 5. So size of this array is 5. Now what we do is we initialize I is equals to 0 as it is a 0 index based data structure, and we go up until 5 minus 1, that is 0, 1, 2, 3, 4, and just we print. Now what this will print is this will print something like this. Array 1 gives us the element 1. Array not 1, this is 0 index, this is array 0. Now array 1 will give us array 2, array 3 will give us array 2 will give us array element 3, and so on, and up until array 4 will give us the element number 5. So this is how traversal will be done. Now when it comes to insertion, insertion is a big of n task in array. Suppose, let's just suppose that we have an array 1, 2, 4, 5, and I am having an extra space over here. Okay. Now, as it is an index space 0, 1, 2, 3, 4. Now, the task is to element, insert 3 at position 2. Now, position and index. Now, position 2 means is equals to ARR position. Okay. Now, position 2 refers to this location. All right. So the task is to insert element 3 over here. So what we can do is we can simply just traverse up until here, and then what I can say is let's just go one step ahead till the end and ask the element to shift one place right. So 5 will come here, then 4 will come here. Now once 4 is here, this location is there available to insert a new element, So what we'll do is once this part, the shifting part is done, the shifting part is once done, the shifting part is once done, we'll just simply do ARR position is equals to new element, that is 3. So from now on, 3 will be residing here, and because we have shifted, oh, I'm really sorry, just give me a minute. 3 will be residing here, 4 here, and 5 here. And this is our resultant array. So insertion takes big of n. Now, why big of n? Because we have to shift elements. Because we are shifting some elements. We have to shift them one place to the right. So this will take big of n time, assuming that this part has elements and they need to be shifted one place to right. So what is the time complexity? It is big O of n. Now, this is a classic example. This is the example I've just described above. See, this is the initial array. Insert element at position 2. It is zero-based indexing. So what we are doing is we are creating an empty space over here. It's not exactly an empty space. There is 4 over here. 4. The element 4 is over there, but what we do is we overwrite the element. Let me just draw the array once again. 1, 2, this is 4, 4, 5. Indexing is 0, 1, 2, 3, 4. Now what we do is we just rewrite. We just rewrite whatever was here because this element has been shifted to this place and this element has been shifted to this place. So what we'll do is we'll just rewrite the new element over there, and the new element is 3. So 3 goes here, 4 takes leave, and the new element that we need is 3. That is how insertion is done. The once insertion is done, we'll move forward to what and how array deletions happen. Just like we saw in insertion that we need to shift one place right to make space over here, what we will do in deletion will not shift to the right, but from end to position -1. This is position. This is the earlier part of the array. This is position plus 1. This is end. What we'll do is we'll shift these elements to the left. Now, once we shift these to the left, this place will become empty. This place will become empty. Now, the position plus 1 element, suppose 71 was there and this is 77. 77 is there. And 71 is the next element to 77. What exactly will happen is 71 will be shifted to this position, overwriting 77. Suppose 77 was there, 77, 71 came, and it just overwrited the value. Now, instead of 77, the place holds 71. Let me show you one more example. 1, 2, 3, 4. There are four elements. We need to delete this one. So what we'll do is from the end, I'll just shift one place to this, one place to this. So what will it do? It will do is it will result into something like this. 4, 4, 3, 1. Is it done? 4, 4, 3, 1. 4 is there because 4 was initially there. It was just shifted to one place to the left. One place to the left. Now, what we will do is, we do not need to see this element. No, this is not needed. This is already there. So suppose that we have four fingers. We do not need to see this one. What we do is, we'll just decrease the size to 3. Now we will see three elements. Now the size here was 4. Now, whatever the new size will be, what will be the new size for our array? The new size will be 3. Why? Because we do not need to see the last element now, because it has been shifted to one place left, one position left. So we do not need to see 4 from now on. Whatever we will traverse, we will just start from here, go there, and end. No need to go to this part. This part has been cancelled. This part has been cancelled. I hope you get this example. Now, let's move with let's move with deletion. How deletion in an array happens. Let's just okay. So deletion I have already explained. Let's just go with an example. See, I'm taking one more example just to make sure that things are pretty clear. This is an array. 1, 1, 2, 3, 4. Now we need to delete this element. What will happen is we shift one place from left. Okay, 5 is also there, so I'm just adding 5. Just shift from this place. This comes to here, this comes to here, this comes to here. The resultant array will look something like the 1, 3, 4, 5, and 5. The size here is 1, 2, 3, 4, 5. So index base it is 0 to 4. All right, so size is 4. All right. Now we do not need to see this element because this is a repetition. This is the same element. It has just been shifted to one place left. So we need not to see this element from now on. So what we'll do is we'll just decrease the size. Size equals to size minus 1, and the new size will be 4 minus 1, that is 3. So index base it is 0, 1, 2, 3. Now on, this is the resultant array that we need to consider from now on. Now, to summarize everything that we have learned today, arrays are something extraordinary. Why? Because arrays provide an efficient indexing based only on the elements. We do not need to have any mathematical functions or any loops just to access the elements. These are constant runtime applications that are happening in the array. Now, traversal is straightforward using loops. The time complexity is again big of n. The time complexity of accessing elements, the time complexity of accessing is big O of 1. Traversing, it is big O of, traversing is big O of n. And insertion and deletions require shifting. So insertion and deletion, they also require big O of n. Now, why arrays are important? Arrays are important because these are the fundamental building blocks for the next data structures that we might learn. And for a fun fact, arrays were the first data structures implemented in almost every programming language because arrays represent and reflect how registers, flip-flops are designed, are fabricated in the memory itself. Suppose we have a block of PCB over here. The flip-flops are something like this: 1, 2, 3, 4, 5, 6, 7, and so on. So these are contiguous memory locations. An array represent this same thing, and that is why arrays are the most beneficial thing when we have to learn data structures and algorithms. Thank you.